Hello grade 10. I hope you are all fine. In this video we are going to correct the exercises from the book. But before we start, we will remember a bit about this chapter. So this chapter is about motion, and motion is a change in position with respect to a reference point or frame. Now, for your class, I have two important types of motion. The first one is the uniform rectilinear motion. The second one is the uniformly accelerated rectilinear motion. In the first one, the velocity is constant. And since the velocity is constant, I'm not changing velocity, the acceleration is going to be 0, so no acceleration. And the equation will be x equal vt plus x0, where v is the velocity that is constant and given, and x0 is the initial position also given. Whereas in the uniformly accelerated rectilinear motion, the velocity is not constant, so the acceleration won't be equal to 0. The equation will be x equal half at squared plus v0t plus x0. A is the acceleration, and v0 is the initial velocity, and x0 is the initial position. Now, let's start correcting the exercises from the book, page 173, number 1 to 6. Number 1. What is a uniform rectilinear motion? A uniform rectilinear motion is a motion in which the trajectory is a straight line and the instantaneous speed is constant. So I have to have two conditions. The first one about the trajectory and the second one about the instantaneous speed. Number 2. True or false, correct the wrong statements. We are in a uniform rectilinear motion. A. The acceleration is constant. This is false because the speed is constant, the acceleration is 0. In this type of motion, I don't have acceleration. B. The speed of a moving object is constant. This one is true. C. The average speed between any two instants is equal to the instantaneous speed. That is also true. And D, the velocity vector of a moving object changes its direction during the motion. D is false because, first of all, rectilinear means a straight line. So if the velocity vector is going to change the direction, I'm going to have different kinds of trajectory. This is first. And second of all, the acceleration won't be equals to 0 since I have a change in the velocity. Number 3. An object moving with a uniform rectilinear motion has a constant speed v equals to 5 meters per second. Determine its time equation if at t equals to 0 its abscissa is 1 meter. So since we have a constant speed and uniform rectilinear motion, the equation is x equals vt plus x0. So v equals to 5 meters per second, constant, this is given, and at t equals to 0, the abscissa equals to 1 meter. This information gives us x0, and if we replace each term by its value, you will get x equals 5t plus 1. Number 4. A car moves with a constant speed of 25 meters per second on a rectilinear track. What is the distance traveled in 10 minutes? So, the trick here is to transform the 10 minutes into seconds because the speed is in meters per second. You cannot use a time in different units. So, first of all, v equals 25 meters per second. This is constant. The distance in 10 minutes, so 10 minutes is 10 times 60, which is 600 seconds. D equals v times t, 25 times 600 equals to 15,000 meters, or simply 15 kilometers. You can keep the answer that you want. You don't have to transform it to kilometers. Number 5. What is a uniformly accelerated rectilinear motion? So a uniformly accelerated rectilinear motion is a motion in which the trajectory is a straight line and its acceleration is constant. I also have two conditions, but this time the second condition isn't about speed, it's about acceleration. The acceleration is constant. Number 6. True or false, correct the wrong statements. So, in a uniformly accelerated rectilinear motion, A, the instantaneous speed is constant. This is false. If the speed is constant, we wouldn't have acceleration. And if we don't have acceleration, the motion couldn't be in uniformly accelerated rectilinear motion. B, the acceleration is of the same sign as the velocity. False. It's not necessary. They could have different signs because the motion could be accelerated or decelerated or retarded. So they don't have to have the same sign. And the last one, the acceleration is proportional to time. False. The equation is, I'm sorry for this inconvenience, it's x equals half a t squared plus vt plus x0. You have it, but I don't know why it didn't take it here. So the acceleration is not proportional to time. And that's it. Thank you very much.